like to take this opportunity to welcome our speaker, Petrus, who will be taking us through going international using Unicode in Elixir. So, Petrus, you can have the platform. It's yours.
Thank you very much, Tracy. Thanks for having me. I'm very glad to be speaking at ElixirconfAfric. Thanks a lot for organizing it for the second year in a row. I was attending some of the talks last year, and I was very chuffed that you organized it last year around. So I'm glad to be giving a talk this time and not just watching. So I'm talking about Unicode CLDR project, and what it is about really is translation. It's translating your software, and I know that this is a problem for a lot of us building software products, especially in a place like Africa, where the markets are very fragmented and people speak different languages. They come from different cultures. You have a lot of diversity, and solving all of that or building one beautiful user interface with your software and doing all of that in English would cut out a lot of potential customers. For example, in Francophone Africa, or in some of the Portuguese-speaking countries in Africa, or if you want to go to the Middle East or Europe. So we all know that you can translate software. You use gettext for that. But gettext only gets you so far. And this talk is just to try and make it easy to wrap your head around what needs to be done if you really want to go far when it comes to translating an application, and what tools are available in the Elixir ecosystem. I'm giving a talk about it because it's something that I struggled with myself, and I found it difficult to really wrap my head around it. It's I had used gettext before, and I didn't really know what the limits were. And then I realized that there's this other thing called CLDR that we can use, but it's a difficult thing to get started with. It's difficult to know where to start and which kind of problems you can solve using it. And then it also has its own limitations. So let me take a shot at just giving you all a quick overview. Please feel free to interrupt me while I'm talking if there's something that's ambiguous, or if you have a question or something. I'll try to keep the slides relatively few, and then I'll demonstrate a few things in the terminal or in an emulator if I can. Cool. So let's get started. We're talking about translation, which in software is internationalization and localization. It's two different things, but all it means is the internationalization side, you wire up your app in such a way that it can be translated. And then when you localize it, that's when you translate it for some specific locale or language. Now, locales can be tricky things, but let's just start with what it looks like. So this is a screenshot from an app that I'm working on, an e-commerce app for airport terminals. And you'll see a lot of different content in here. And here it's rendered in English for an English-speaking locale. The next screenshot, I'm showing you the same thing, and it's very similar, but it's rendered for Italian. Now, you have to really squint to see some of the details, some of the changes, but some of the obvious ones is, for example, there's this prodotti di tendenza at the top. Now, that's a static piece of string, and it's exactly the type of thing that you would use gettext for. So trending products would be the English base string. You mark it up in your code, it gets translated, and your Elixir code uses gettext to spit out the Italian translation when the locale is set to Italian. But then there's something else as well that's not that easy to spot, and that's the price. If we look at it in English, it's formatted in a specific way. And if you grow up in an English country, that's roughly how you would expect prices to be formatted. But now if you are from Italy or France or someplace like that, it looks slightly different. And you'd still understand it if it was formatted the wrong way, but it just feels a little bit weird. And going further than gettext and using CLDR just makes your app feels a bit less weird if you do it well. So that kind of thing is done with CLDR rather than gettext. And then thirdly, there's a chunk of text in the product description. Now, that kind of thing is not handled well with gettext because it's in your database. It's not in your code. You can't extract it using the same tools. So that's also not something that CLDR can do for you on the fly. It's something that you have to do in your database itself. So that's the third way of translating text. You've got gettext, and then some dynamic strings you translate with CLDR, and then there's some content that neither of those can help you with that you have to save in your own database. And for that, there's also some tools available that I'll show you right at the end. So that's what these two look like next to each other. Very similar, but there are some differences. Cool. So as I said, internationalization, you hook it up, and then localization, you actually go ahead and translate things. But first off, if you're translating things, what do you translate it to? You translate it to some specific locale. And locale is mostly a language, but it's not just a language. It gives you a lot more information than that. Typically, we would get this locale as an accept languages header coming from an HTTP request. And you can have a plug in your Phoenix app that parses that and sets the locale for the process on the server side. Now, the locale is mostly a language, so it would be English, for example, or Italian, but then it can include a country code, which is actually referred to as territory codes when it comes to localization, because countries and their political, like their extent can be it can be politically charged to have conversations around which thing is in which country. So we normally refer to territories. There are a bunch of different ones, I think about 300 or so. And you should know that any locale string, a locale string could be as simple as just EN or IT for Italian or FR for French, but that would assume the default territory. And the default territory is the one with the biggest the biggest population of native speakers of that language in the world. So for English, that is the US. It's not the UK, even though English comes from the UK. For French, it's France. But for Portuguese, for example, it's Brazil. So if you just have PT for Portuguese as a locale, that would imply Brazilian Portuguese over the Portuguese spoken in Portugal. But it's not just languages and territories. There's a lot more that can be conveyed in a locale, especially around the formatting of numbers and dates and the collation of strings and all sorts of things like that. So all of this is standards driven. There are standards that are published to say what can be in these strings and what format should those strings be in, and so on. So this would be a standards compliant locale string for English in Australia. And then that -u denotes the start of a keyword list. So after that, we have keyword lists, where TZ is for time zone, Australia, Sydney, and CF is for currency format, of accounting currency format. Now, we don't necessarily need to know all of this detail. It's just good to have it in the back of your mind that all of this is possible. Because all of our software is running in some kind of locale. Some decisions have been made for us in terms of all of those things. So, for example, if I, let me see if I can make this a bit bigger. Yeah. So if you just type locale into your terminal, it'll give you some kind of locale. Your operating system has settings for all of these things, and you'll see things like the numeric locale there and the time formatting and things like that. But also your database. If you're working with a database, let's open Postgres here. You can query PG settings from the PG settings table. You can query a bunch of locale related settings. Now here, both on my operating system and in my database, it's just using defaults, and that's fine. And mostly that's fine, but it's good to know that they are there and you're using them, because then you can, when you come to actually localizing an app, you know where to change them if you need to. Let's get out of here and go back to the presentation. Sorry, we are here. So there are locales everywhere, and they're governed by some standards bodies. So there's a body that publishes standards on the locale strings used on in browsers and so on. And there's also the Unicode consortium. Now they do emojis, they're famous for that, but they also collate lots of different locale information from different languages and cultures and put them into a format that they can be used in software. And that's what CLDR is about. So CLDR stands for the Common Locale data repository. And it's a project of the Unicode consortium. They do all the hard work. And then us, using our Elixir code, can use a few packages to leverage that in our code, which I think is pretty cool. To show you a bit about what they look like, the Unicode consortium, it's a non-profit. So it's one of those things that everyone can benefit from. Somebody pays for it, but it's not us, and we can just use all of the output, which is great. As I said, they're famous for managing the emojis we have in a lot of the software we use, but they do also do other projects, and the CLDR project is one of them. Now, as part of the CLDR project, they publish a big XML dump of data that basically puts together lots of rules for how to format different things in different locales. It's as simple as that. They also publish it more recently in JSON format. So I can show you what that looks like. They publish it here on GitHub, so you can go ahead and download that to your local machine if you want to. I've done that, so you don't have to. So let me just quickly have a look at what that looks like. So if we say ls CLDR, it's sorry. Okay, so it's just a bunch of directories, but inside of them there are a lot of JSON files. So to have a look at the extent of this, I've got this command here to sorry, where are we? I think I have gone off the edge of my terminal. Yeah, so I've got this command here to search through that directory and look at all the JSON files and just count them. So how many of them are there? About 35,000 JSON files. Now, each of these is a file with some kind of rule of how to display things in different languages. So there are a lot of them. It's a lot of data. To see how much data it is on the disk, it's about a gigabyte worth of data. So if you want your software to be able to translate anything into any locale known by the CLDR repo, it needs to have about a gig worth of data in memory to be doing that, and that's a lot. So let me get back to my presentation. Yeah, so that's CLDR. But when it comes to translating things, we usually don't start there. Gettext is baked into Phoenix, and we all use that quite often in our apps. It's hooked up when you start a new project, and that has a history of its own. It's been around for a long time. It started as this GNU project with an open source project, and really what set it apart over other ways of translating stuff is gettext use the approach of using the message itself as the ID. In many other localization frameworks, the developer has to come up with an ID of their own for each string, and that complicates things a lot. It means that it's more difficult for the translator as well to figure out the context of where things are being used. Whereas with gettext, you just mark up the string itself, and that is the ID of the string to be translated. So gettext comes with a rich set of tooling. There's things like Poe Editor where you can manage your translations online. And there's Elixir gettext as well that you can use if you there's Elixir gettext that's kind of hooked up to work well with Phoenix from the get-go. If you want to have a better idea of how it fits together, there's this talk by Andrea Leopardi where he's one of the authors of the Elixir gettext package, and he explains the whole idea of how it's built. And it's really about compiling a lot of the translated stuff out of your code, and then compiling it or extracting a lot of stuff, compiling the translations back in, and then at runtime it's really, really fast to translate things. There's not a lot of computation going on. It's literally just picking things from maps or doing something even more efficient than that, if I'm not mistaken. So the workflow is you have your code, you mark up pieces of string in your code. Those would be static pieces of string, like, for example, that trending products string that I showed you. And then that gets translated by a translator, or by, you can auto translate it if you want, and then it gets compiled back into your application. So that's the kind of workflow, and that's great. But for certain things, it's not good enough. It has its limitations, and the limitations are things that are variable. So there's no real way of using gettext to format a date, for example. Also not a currency, and also not other types of numbers. So to give you an idea, sorry, let me just get back. That is where CLDR comes from, or comes in. So let me quickly give you an idea of what that might look like in code. So if we just go into this project here and start up an IX terminal, then I'll show you just a few samples. So for example, here we have a CLDR datetime toString function that we're calling, and we're giving it this timestamp, and we're saying short format in the English locale, and that would come in like this. Now, if we do that same thing in Portuguese, let's say, it looks slightly different. You'll notice that the month and the day is the different time around, and they'd use 24-hour format rather than the AM PM that we use. If we want to see something a bit stranger, we could do Arabic. It gives us a few warnings because it's slightly less efficient than the other ones. But you'll see that here it uses a completely different numbering system, for example. Now, the fact that you can do that on the fly in your code is quite amazing. And I thought that's quite a superpower to have as an Elixir developer. We can change this to the long format, and then it looks a bit different. Let's do that for English again, and then Portuguese. So this is using the Elixir CLDR library. Let me see if I have it open here. Elixir CLDR. So Elixir CLDR is not just one library, it's a whole suite of libraries. It's created and maintained by a guy called Kip Cole, who is Australian, but he lives in Singapore, if I'm not mistaken. And he is a prolific contributor to the Elixir ecosystem. So CLDR is the best entry point, but because these things are so data intensive, it's been split up into lots of different packages. So you only use the ones that you need, and then at compile time, it compiles through all of that data to make things fast at runtime. If you wanted to just compile everything, you could theoretically, but it would add a lot of compile time to your app, which sucks. So that's why it's split up into lots of different packages, which concern themselves about different parts of that big data set, the big 1 gigabyte dump of JSON data that CLDR gives us. And then it gives you, the developer, the flexibility to only pull in the bits that you need. So there's packages around dates and times and units of measurement, numbers, calendars, all sorts of things like that. So the example I just showed you would have used the calendars package, and also the dates times package. So that is roughly how it fits together. Let me show you another example or two just for interest's sake, and please feel free to interrupt me if you have any questions. Cool. So here we have a number, for example, that we want to format to string, and you can see that the thousands are separated by commas, and then the decimal is a point. In some European locales, it's the other way around. So the thousands are separated by dots, and then there's a comma at the end. And then, as you will have noticed, for Arabic, for example, they have their own numbering system, so it's completely different set of characters that are being used. And there are lots of these types of numbering systems out there in the world. You don't have to go far. I think you can just go across the border to Ethiopia and you'll see some really funky symbols and stuff being used. So that's what numbers look like. And then formatting currencies, you saw that in my one screenshot that I showed you, but here's euros, for example, formatted in English versus Portuguese versus Arabic. In Arabic, you will notice that things are the other way around. The euro symbol is on the right. Yeah, so that's what CLDR can do for you. You hook it up in a way that's very similar to the way that gettext is hooked up, except that you have to hook up each of these individual packages separately. So you have the CLDR base package, and then you add different packages to that. And then at compile time, it figures out what parts of those that big CLDR data, ball of data, it needs to compile into your app for you, so that these kind of conversions can happen on the fly in your software very quickly, like while a request is being made, for example. So that is CLDR, and that's great. And I've shown you kind of what it looks like. But now there's one piece of that is still missing. If we go back to that initial screenshot that I showed you of an e-commerce interface, some of the text is static, and that's handled by gettext. Some of the text are variables like dates and times and currencies, and that's done by CLDR. But now, how do you do the rest? How do you translate the product descriptions, for example, or if you have some marketplace and app that you're building and you have to translate the profiles? The same author behind that big suite of CLDR packages in Elixir also wrote something called CLDR Trans. It's a fork of a different package just called Trans. And what it looks like is, let's just find it here quickly. This is not the best entry point. So it's a very new package. You'll see that almost no one is using it yet, but I happen to think that it's a very useful package. So just hear me out quickly. What it looks like is down here, you would have a schema. Let's say you have an article schema and you have your fields. And then all you need to do to use Trans is to hook it up to your app initially, and then to say which fields it translates. And then you add this translations field to your schema. And what that is a JSON field. And inside it manages translations for you for that schema. So for articles, if you're doing both the title and the body and they're both being translated, both of them would be managed inside of that JSON field for all the translation values you have. So you'll still have your English value title and English value body field in the database, but then you'll also have a JSON field called translations. And inside that, you'll have for each language a JSON dictionary of translations for both of those fields. And then you hook up your chain sets so that you can use this with Ecto the way you would anything else. And then you're off to the races. You can have a form that includes translations from the get-go. What that looks like, I can show you quickly. So here is an admin interface that I'm working on, just as an example. So let's look at this product, for example, at the Muscat airport. It's got a title and it's got a description. Now, for English users, this is fine. It's an English title and an English description. But in the same database, there are translations. And now these are not stored as individual fields. These are all stored as a JSON dump using CLDR Trans. And here I've built a tool where I can go and auto-translate from the English to the target language. So if I hit save now, then this Arabic translation will be live in my app, and it's living in a JSON field in my database, and CLDR Trans is helping me to translate that on the fly in a way that's not really any slower than it would be to just query the original base language, which is English in this case. So that's what CLDR Trans can do for you. And I happen to think that that's a very simple way of solving the problem of managing software across multiple locales. Cool. So that's roughly it. Thank you very much for hearing me out. I'm wondering if there are any comments that you might have on what I've shown you, or any questions, of course.
Thank you very much, Petrus. This was an amazing talk, and I'm sure we have all learned a lot from this. So any questions from the audience, feel free to type it on the Q&A.
Yeah, so while you're thinking of questions, let me just show you what this looks like in practice. So the front end that I've been building is a web front end. So here we're querying it from the English phone. And if I say now, let's do the Italian one. It's loading this interface in English because the accept language header is coming at my app, at my Phoenix app, with a locale of EN. You select a flight, you select an airport, and you'll see here that everything is in English in the way you'd expect. And then you have the screen where you can add things to your cart, and again everything is English. If we take this exact same website, but now we're looking at it from a phone that's Italian, then you'll see things just swap around. So if I had an Italian iPhone and I was visiting the site, you'd see that the whole thing would just pop up in the different languages. As easy as that. So from the user's perspective, there's no real difference. You don't have to manually switch between the one or the other. It's just that if your phone is set to Italian, then it should just speak Italian to you most of the time, if that's available. Yeah, how these things work as well is that it's usually not a single language. So an accept language header can give you a list of languages that you as a user would prefer, and then the server picks the one that's the highest up in that list that it can actually support. So if you with your app don't want to support Arabic, that's fine. And if a user has a phone or a browser that is set to Arabic, they'll come to your site and your server doesn't have any Arabic to send back, then it'll fall back to the second language or the third one, whatever that may be. So luckily with the suite of CLDR software that we have available in Elixir, that kind of logic you don't really need to think about too much. It gets handled in a plug for you, so that you just you can just build your app and translate to the locales that are valuable for you. But yeah, any questions or comments?
Yes, there is a question that has been asked. So good. I'll just read. How does Phoenix gettext do the translation? Does it refer to the external system for this?
Yes, so the gettext workflow is you mark pieces of string in your app. You just wrap it with a function call, and then you say mix gettext extract, and it takes all of those strings in your code and extracts them into a text file, which then gets translated. Then you take that translated text file and it gets compiled into your app. So gettext doesn't actually do the translation for you. It's just a tool for marking up the strings, extracting them, and then baking them back into your application when you get to deploy it or when you run it. The translation itself, I use PoEditor, which is an online tool. You can upload the file that gettext extracts, and then you can collaborate on it online with the translator. Or you can just take that file and take it to Google Translate and translate the whole file. That's also a possibility. Yeah, any other questions?
No, there's no any other question. Thank you very much.
Cool, then.
That was
Yeah,
fun.
thanks a lot for joining me.